Hi students, welcome back to the online classes. Today we are going to start a new lesson, that is friction. So in the previous lesson we have studied about forces. We have seen different types of forces. So how many different types of forces are there? There are mainly two types of forces. One is contact forces, another one is field forces. So there are two types of forces, contact forces and another one is field forces. In this contact forces, what we have learned, contact force is the force which is applied, which is exerted due to a direct physical contact. Because of the direct physical contact, the force was exerted. Such forces are called as contact forces. So in this we have learned about muscular force, frictional force, normal force and tension. So now we are discussing about this frictional force. Now we are discussing about frictional force. In the previous chapter, what is the definition we have learned? So we have learned the definition of friction as friction is a resistance. Frictional force is a resistance for the motion of the body over another surface, So we have learnt this definition. So now we will slightly modify this definition. So we have a separate chapter for friction. Why? Because friction is very important in our life. So in this chapter we will learn what are the factors affecting friction, how the friction was advantageous for us, how many different types of frictions are there. So we will experience the friction each and every time in our daily life. That's why you have a special chapter about the friction. So let us learn about friction. So we will get a slightly different definition than we have learnt in the previous lesson. So let us see what is meant by friction. So I will consider a plane surface. I have considered a plane surface and a wooden block. I have considered a plane surface and a wooden block. I have applied some force to this wooden block. I have applied, so initially this wooden block is at rest and I have applied some force to it. I have applied some force to this wooden block. So what happened? So after traveling some distance, the wooden block came to rest. Again this wooden block stopped at some certain position. So if any object is moving towards you and you want to stop that object, for example, if any object, your friend was running towards you to strike like this. So you are playing something with your friends and he was coming with speed and pushing like this. So what you have to do, if he was doing like that, to stop him, you have to oppose. He was coming in this direction. To stop that object, to stop your friend, you have to apply in this, you have to apply the force in this direction. So in order to stop any object, for example, any object is moving like this. So any object is moving like this. So moving in this direction. So an object is moving in this direction and you are here and you want to stop this object. So in which direction you will apply? You will apply force in this direction? No. You have to apply the force in this direction in order to stop this object. An object was moving in this direction. You want to stop that object. So you have to apply force in this direction. So this is the moving direction. We will call that as direction of motion. So this is what we call direction of motion. Direction of motion. What is the direction of motion? This object is moving in this direction. So this is the direction of motion and this is the applied force in order to stop that object. Applied force in order to stop this object. If the direction of the motion of the object was in this direction, you have to apply force in this direction in order to stop that object. So here, so in the example, the wooden block is kept on a plane surface and I have applied some force to it and it was stopped there. I have applied force here, the wooden block is stopped here. So, who has stopped that block? Who has given force to stop this block? If the object is in motion, someone has to apply the force to make it stop. To stop this object, some force should be act on it. So, here initially this is addressed. Why this came into motion? Why? Because I have applied this force, I have applied a force, but who applied the force to stop this object? Who applied the force? The force was applied by the surface of the force is applied by the surface of the plane. The wooden block, an opposite force is applied on the wooden block by the surface of the plane. Here an opposite force is applied by a force opposite to the direction of motion. A force opposite to the direction of motion is applied by the plane surface on this wooden block. That force is called as frictional force. Here what was happened? The object is moving in this direction and this plane surface is applied force on this wooden block to stop the movement of to stop the object. This plane surface has applied some force on the wooden block here. So, in the example we are discussing, a opposing force is applied by the plane surface is called frictional force. By the plane surface on the wooden block, the opposing force is applied by the plane surface on wooden block. That opposing force was applied on wooden block. So, such force is called as frictional force. I have explained the frictional force by taking some example, but this is not the definition. Okay, we will see it later. So, we will see the definition later. So, now let us find out what are the forces acting on let us learn about the free body diagram for a body which is in motion. Let us analyze the free body diagram of an object which is in motion. So, here I have considered a wooden block on a plane surface, So, what is a free body diagram? So, let us draw free body diagram. So, this object is in the motion in this direction. This wooden block is in the motion in this direction. So, let us list out what are the forces acting on this wooden block. So, what are the forces acting on this wooden block? Gravitational force, which is equal to the weight of the wooden block. Weight of the wooden block is nothing but gravitational force acting vertically in downward direction. So, the weight of the wooden block acting vertically in downward direction. So, it does not fall because of this force. Why? Because this plane surface applies an upward force. Why it does not fall? Why? Because this plane surface applies a force in the normal direction. That force is nothing but normal force. This is the normal force. So, these are the two forces acts in vertical directions. Vertical forces, we will call these as vertical forces, and the object is moving in this direction. This plane surface offers an opposing force. It is denoted with small f, that is frictional force. This is frictional force. Since the object is moving in this direction, the frictional force will act in this direction. So, this is the direction of motion and this is the frictional force offered by the plane surface. So, is the object is moving in a vertical direction? Here in this example what was happening? The object, the wooden block is moving in the horizontal direction only. It doesn't moves in the vertical direction. It is not moving in vertical direction. So, it doesn't have, this block doesn't have any movement in vertical direction. What does that mean? That means if an object is at rest, here you can observe this object is at rest. Why this is at rest? Why? Because the net force on this object is 0. The net force on this object is 0. Here the object is not in vertical motion, it is not moving in the vertical direction, it is not moving in the vertical direction. Hence, the vertical forces, the net force on the vertical direction is 0. Net vertical forces is 0. Net vertical forces is equal to, net vertical force is equal to 0. So, find out the net vertical forces. So, upward direction is taken as plus and downward direction is taken as minus. So, n minus w is equal to 0, n minus w is equal to 0. So, n is equal to minus w. If you bring this minus w to the right hand side of the equation, then it will becomes w. Here normal force n is equal to weight, normal force n is equal to weight. So, whenever if you observe any object is at rest in vertical direction, this object is not moving in vertical direction. That is why this normal force is equal to W. Then the normal force acting on this block is W. What is the, if you observe, if there is no motion between, if there is no motion in vertical direction, normal force will be equal to W. But in horizontal direction, does the forces are 0? No, in horizontal direction the forces are not 0. That is why it came to rest. Some net force is acting on this object. So, what is that net force? Frictional force, that is only frictional force acting on this direction. So, F net, this is especially in horizontal direction, horizontal direction. So, what is the forces? This is the direction of motion only. Here V is the velocity of the object only, it is not force. So, here this velocity of the object was decreased by this frictional force applied by the plane surface. This velocity of the object is decreased by applying some force. What a force we can do? A force can increase the speed or a force can decrease the speed, a force can change the direction. So, what is that force changing this velocity of the object? The force is, the net force is only the frictional force, only the frictional force F. Frictional force here, the horizontal forces acting on this object is only frictional force. So, what did this net force on the object? What is the effect of this net frictional force on the object? So, what is the effect of that frictional force? The effect of the frictional force is it opposes, it decreases the velocity of the object. It decreases the velocity of the object. Why? Because this frictional force is acting opposite to the direction of the motion. This frictional force is acting opposite to the direction of the motion, and hence that frictional force decreases the velocity of the wooden block. That frictional force decreases the velocity of the wooden block. So, in order to understand about the frictional force, let us discuss an activity to understand the friction definition. So, let us discuss an activity first. So, activity to understand about friction. Activity to understand friction. So, consider a table, and place a trolley on this table, place a trolley. So, this trolley is having some wheels. So, place a trolley on this table, tie a thread to it tie a thread to it and pass this thread through a pulley and attach a weight hanger, So, here you can place some weights, So, these are the weight hanger. So, you can place some small weights. For this hanging object, you can add weights. So, place a wooden block on this hanger. So, place a wooden block on this trolley. So, place a wooden block on this trolley. So, this is the block. So, if you add the weights to this weight hanger, the trolley will move in this direction. So, this is the, if you add weights, this is the direction of the motion. This is the direction of motion of these two objects. That means, the direction of motion of trolley and block. So, here you have attached this string to the trolley only. So, if you add the weights to this weight hanger, a downward force will be applied and some force will act on this trolley. So, force is acting in this direction, which makes the trolley to move in left hand side direction. So, is the block moves along with the trolley or not? Yes, the block will move along with the trolley. But the force is applied only on the trolley. Why it is coming? Along with the trolley? So, what makes the block to come along with this trolley? So, here the force is applied only on the trolley, but here no forces are acting on this block directly. So, which force is making this block to move in this direction? Here there is a reason for the motion of this object, motion of the trolley. Why? What is the reason? You have added weights to the hanger. So, some force is acting on this trolley, but why this block is moving? The reason is the frictional force is acting in this direction. So, here this is the trolley, this blue colored block is the, let us imagine this blue colored block is as trolley, and if you apply force on this blue colored trolley, why this wooden block is moving? Why? Because the frictional force between these two surfaces is acting in this direction. The frictional force is in this direction. If you speed up this object, what happens? If you speed up this object, what happens? The wooden block will move in this direction. So, initially for a small weight, if you add small weights, this block will move. This is the frictional force direction. The block will move along with the trolley. So, if you keep on increasing the weights, the trolley will accelerate. The speed of the trolley increases. If you add weights, the trolley will be accelerated. So, let us imagine that you are traveling on a bike along with your father or your brother. So, you are traveling on a bike with your brother. If he suddenly increases the speed, in the person who is behind the driving person, he will experience a force like this. If he suddenly increases speed, what we will experience? We will experience a backward force. Here, accelerated means change in speed or increase in speed. In this case, especially increase of speed. So, if we add weights to this weight hanger, the force will be increased. If you add weight to this hanger, the force will be increased. That means this trolley gets accelerated, its speed increases. So, whenever the speed of the vehicle increases, you will experience a force in this direction. You will experience a force in this direction. So, that force is called as pseudo force. So, this block will experience pseudo force due to acceleration of the trolley. Pseudo, the word pseudo means not real, not real. So, a vehicle is accelerating in this direction, no one was applied a force on you, no one was applied, but you will experience that force, you will experience that force, but no one is applied on you. So, that is why it is not a real force. If someone was beat with a punch, then he has applied some force. So, if someone is accelerating the vehicle, for example, you are traveling in a bus, the bus was suddenly accelerated, what will happen? You will move in this direction, you will experience a force in this direction. So, that is why it is not a real force, that is why we will call it as pseudo force. So, if you keep on increases the, let us assume that you have placed a small weights only. If you place small weights, the block will move along with the trolley, the block will move along with the trolley. If you suddenly increases the weight, the block will slides in this direction, the block will slides in this direction because of the pseudo force. If the block slides in this direction, so this is the frictional force direction. So, this is the frictional force direction. So, what it was doing? The frictional force is opposing the relative motion between the surfaces of the blocks. Here the block trolley surface and wooden surface are there. The frictional force opposes the relative motion between these two surfaces. So, the definition of the frictional force you will learn in this lesson is frictional force is a force which opposes the relative motion between two surfaces in contact, So, here the surface of the trolley, and the surface of the wooden block, if these two surfaces are in relative motion. So, for example, if you observe, this blue block is moving in this direction and wooden block is also moving along in this direction. Is there any frictional force between them? Yes, the frictional force between this trolley and wooden block makes the wooden block to move in this direction. Here I was applied the force on the wooden block only, but why it was coming in this direction? So, I have holded the blue block only. Here the yellow block was coming along with this block. Why? Because the frictional force between the surfaces. Here the both are rest in each other. So, these two blocks are in motion with me and these two are in rest with each other. This block is in rest with respect to blue block and this blue block is in rest with yellow block. So, these two are not in relative motion. Of course, these two bodies are moving together, but these two are in rest to each other. So, according to yellow block, this is at rest, according to blue block, yellow block is at rest. So, if you observe any relative motion, if there is any relative motion, some frictional force will be offered between these two surfaces. That force is called as frictional force. So, even there is no relative motion between these two objects. So, here you can observe there is no relative motion between these two objects. Here there is no, the total complete two blocks are moving together, but there is no relative motion with each other. So, when compared with one other, they are at rest. Of course, two blocks are moving at each other. So, here the two blocks at rest with each other. So, at this case there is some force acting between these two surfaces. We will call that force as static friction. We will call that force as static friction. Static friction. For example, have considered a wooden block. Let us imagine it is a very heavy weight wooden block. So, it is a very weight wooden block. So, I have applied some force. So, is this force enough to move this object? I have applied a very little bit of force. So, this force is not able to move this object. So, who is applying force from the other side to restrict the movement of this object? So, some force is opposing this applied force. Some force is applied, some force is opposing this applied force. I was applying some force, but it is a little one. Some force was applying from the opposite side. So, even the block is at rest, if you apply some force, this is the applied force, some force will restrict this the movement of this block. So, that force, so here this force is nothing but friction. So, this frictional force exists even when the block is at rest. So, even when the block is at rest, there is some frictional force. So, that force we will call it as static friction. So, even the block is at rest, even this surface of the block is at rest with the floor, with the plane surface, then also friction will act on it. So, that friction is called as static friction. The friction which comes into play when there is no relative motion between them. So, here there is no relative motion. I have applied some force, but there is no movement in this object. So, even though there is no movement in this object, there is some frictional force acting between these two surfaces. So, that frictional force is called as static friction. So, it is a different types of friction. So, initially we have learnt about friction. We are seeing about how many different types of frictions are there. So, friction which comes into play when there is no relative motion, between the surfaces in contact, So, let us discuss another example. For example, a large luggage box is there. So, it is a very large luggage box is there, and you are trying to push this box. You want to displace it from here to here. You want to place this box at this position. So, what you need to do? You have to apply some force. Initially, you are not applying any force. What is the friction offered? So, this is the surface of contact with this plane surface. So, you need to displace this object. So, initially you have applied any force, you did not apply any force. So, here the static friction value is 0, Now, you are applying some force, very little bit of force. You have applied 1 Newton of force. How much force you have applied? 1 Newton of force was applied. Since it is a very large box, 1 Newton of force did not make it to move. The box did not move. With the 1 Newton of force is not enough to move that object. You need to apply more force. If 1 Newton force is applied, this box does not move. Why? Because it is not enough. So, some force was opposing this 1 Newton. So, what is that force? Static friction force. The static friction exists there. So, if you apply 1 Newton of force, the static friction value changes and the static friction value becomes 1 Newton. So, if you are applying 1 Newton of force, why it is not moving? Why? Because the static friction prevents the motion of this object, prevents the motion of this luggage box. So, if you apply 1 Newton of force, how much static friction was developed? 1 Newton of static friction is developed. So, if you increase the force, it is not moving, then what you will do? You will increase the force. So, you have increased it to 2 Newtons. Again the block does not move. Which force is opposing that block? That static frictional force is opposing. If you apply 2 Newtons of force, this static friction value becomes 2 Newtons. So, if you keep on increasing, you have increased it to 3, the block does not move, again the static friction value becomes 3. So, if you apply 5 Newtons of force, the block starts to move. if you apply 5 newtons of force, the block starts moving on this plane surface. So, here maximum static friction, how much static friction it can apply? This plane surface can apply 5 newtons of static friction force. There is a limit for the static friction value. So, here if you observe the example, if you apply 1 Newton of force, static friction value 1 Newton. If you apply 2 Newtons of force, static friction value 2 Newtons. If you apply 3 Newtons of force, static friction value 3 Newtons. Hence, this friction we will call as self-adjusting friction. We will call the static friction as self-adjusting friction. So, the value of the static friction will self-adjust itself. If you apply 1.5 Newtons, then the static friction value becomes 1.5. But there is a limit for the static friction value. From this example, what is the limit? 5 Newtons is the maximum static friction value. There is a limit for the static friction value, and it depends upon the plane surface nature, whether it is a smooth surface or rough surface. So, here a maximum limit will be there for the static friction value. We will call this as limiting static friction or maximum static friction, maximum static friction. So, with this session was completed. In the later session we will discuss about sliding friction. Thank you.